people to turn up soon. Sorry, guys. James. It's the host. Okay, guys. So welcome to all of you. Just take a seat as we go along, yeah? Welcome to this STIQ Robotics 7th networking event. Despite all the train strikes and so on going on, we seem to have got quite a lot of people here. First of all, I would like to start by thanking the amazing sponsors, Onshape, Hill Dickinson, Cambridge Consultants, and of course also Kaikaku, who will be feeding us at the end of today. So, why or what is STIQ Robotics? So first of all, some of these images are from previous events, as you can see. STIQ Robotics is a series of informal networking events focused around robotics and automation. So we organized these initially then with the idea of encouraging or engaging, promoting, whatever you want to say, the British robotics ecosystem, perhaps with the aim of seeing more and more startups popping up. And have we managed to do this since we started with our webinars in 2020 or with our in-person events in 2022? I'd like to think that we made a difference with all these people turning up and meeting each other and making networks and connections that hopefully lead to more startups. So on that, please network during the breaks. And also take some pictures and so on as well, post on social media, and remember to use the STIQ Robotics hashtag so we make these events a bit more well-known as well. So with that simple introduction, if you have any questions, by the way, about the events, just contact me afterwards, yeah. With that anyway, we move on to Onshape. Well, this is the, there we go. Welcome. Here you go. Do you want to talk to that or to that?
I'll go with the. I'll go free.
So this one you need as well. I'll just put that on you. It's for the live stream. I'll put it there.
Yeah,
there you go. Thank you.
One. Cool. Well, thank you very much, everyone. Hi, welcome to the STIQ event. Let's start off maybe by asking: has anyone here, well, who here uses CAD on a day-by-day? Excellent. Cool. Is anyone familiar with Onshape? This is good. Okay, good start. Right. So thank you for joining me. My name is Simon Horner. I'm the UK and Ireland executive for Onshape. This is my first time doing this event, so if I'm a little bit nervous, that's why. But it's good to see you all. So I'm going to talk a little bit about what is Onshape. If you're familiar with CAD, then you know that SolidWorks is our biggest competitor. And SolidWorks was created by John Hirschtick, and John Hirschtick is the one who created Onshape. So we're very, very familiar with him. I see him every single time when I go to the US. And yeah, it's good to be familiar with each other. The reason why companies are looking at Onshape is mainly to do with collaboration, but also, and I want to discuss this here, put this down, is mainly to do with the fact that companies, and small companies especially, traditional CAD is a very high total cost of ownership. You have to have the hardware, you have to have the ability to purchase it and then do your CAD work on top of that hardware. Onshape completely cuts it out. With Onshape, because it's a cloud-based, cloud-native technology, you don't have to have any of that at all. For a cloud-native CAD technology, what a traditional CAD over traditional CAD, the advantages are very simple. We have advanced collaboration. You can work multiple different people on the same design at the same time. You can access it on any device. And this is secured because you're on AWS, so you don't have to worry about your data being stolen. You can run Onshape on your phone. You can run it on a tablet. And the other great thing about it, with regards to traditional CAD, is that you don't have any crashes and you don't have any updates. So you just log in the morning, and updates are done automatically, and you don't ever have any crashes. This is not created by us, actually. This was created by one of our customers who was trying to sell Onshape internally, which was the 6 zeros. And the 6 zeros, essentially, what this means is that rather than having to worry about doing your work on a day-by-day basis and worrying about all these different aspects of a traditional CAD, you can get down to what you're doing, what you like to do, which is doing your design work. So this is what he sold to us internally. Here we have a few examples of some of the companies which are working with us. You might be familiar with some of them, for example, like Ocado. But I also wanted to give a shout out to, for example, Trek, who is on here somewhere. Trek just released their first bicycle. If you know Trek, their bicycle company, they released their first bicycle last week, which was completely designed inside Onshape. Really proud moment for us. And there's another one as well, which is a boating company in Barcelona, where I'm from, where they are actually now just won an award for creating the yacht of the year, and that was designed entirely inside Onshape. The last thing I wanted to talk about with you all is the Discovery Program, which gives you the ability to try out Onshape completely for free. We understand that having a new CAD tool can be scary, and changing from like SolidWorks or Fusion can be scary. And you had a little leaflet in front of you. And basically what the Discover Onshape gives you the ability to do is to try out Onshape for up to 6 months completely for free. You can log in, there's training courses, there's the ability to try out all of the great things about this cloud-native technology, whilst not having to worry about, oh yeah, next week I'm going to get cut access. So please, I beg you, scan the code, log in. Even if you're not a CAD user, we've got training courses to start you out. You might be a CAD user in the next 6 months. It's a possibility. So I suggest trying it out. That's my presentation. I really love to anyone at the end. Like I said, a bit nervous the first time I'm doing this, so I apologize for the little bit of a wobbly start. But please, come give me a shout at the end. Come talk to me. I'm happy to discuss more about CAD. I'm happy to talk about the advantages of cloud-native technology and improving your lives, really. So, thank you very much. Appreciate it.
Do you have any questions on CAD, by the way, or no? So with that, I also wanted to. What's the one?
Yeah, I don't think I've got the thing.
There you go.
Yeah, we can import directly. You can import almost every single CAD file. SolidWorks especially, we've got translators, so you can keep your history tree, you can keep the metadata. It'll take basically a part file and then recreate it automatically inside Onshape, so saving you have to do it yourself. So, yeah, very cool.
Awesome, thanks for that. And just to mention as well, we're being hosted here by Hill Dickinson, so if you have any questions regarding what patents, how to do your next acquisition or anything like that, you know, the small things in the world, James is sitting here in the front. He also have some team members throughout the audience as well. So with that, we're jumping over to Cambridge Consultants. So does anyone want to take that one? So this one, just use them both together like that.
Okay, thank you. And the slide clicker. Okay. Hi, so I'm Chris Roberts. I'm the head of robotics and automation at Cambridge Consultants, and I'm going to give you a little bit of an introduction to our company, and then Dimitris is going to talk to you a bit more about a project he's been working on. So Cambridge Consultants, we're a group of 800 plus engineers, designers, technologists, and most of us are based in Cambridge in the UK, but we've got offices all over the world. We work as part of the Capgemini group, and we've been going for 60 years working in various forms of deep tech. The way that we work, the way that we do business is people pay us for our time, and we develop technological solutions for our clients. So all the work we do for our clients, they own the product designs we do, they own the patents we develop for them. And we can start from a blank sheet of paper, or we can start from a concept, or we can start from a product and we can improve it. And we'll go from that beginning through all the detailed design, producing prototypes or physically making the first few products if appropriate, and then transferring to manufacture if you want to do volume production. Unfortunately, most of the commercial products we do, which are very exciting, we can't talk about because of commercial confidentiality. So often we develop internal projects that are just for us, not as a product to sell, but more as a showcase to show off the skills and experience we've got. And this is one of the projects that Demetrius has been working on, and he's going to talk to you more about that after I've finished. But if you've got a problem, business challenge, or something where you think technology might be the solution, then come and talk to us afterwards, and we might be able to help. Okay, over to you.
Hi everyone. So yes, this is an introduction into an internal project that we've been doing at CC. We thought it'd be an interesting area to look into and a challenging area, as many of you here might know. And we wanted to see an area where you could combine new technologies to address problems in industry. So why do we need flexible robots? They get most of their reputation from the medical sector, but we wanted to look at areas where you could use them in industry. So automation and handling in complex environments, or radioactive and chemically hazardous environments. So think in a nuclear environment, for example. If you want to go in and inspect somewhere, could you do it with a robot that has no electronic actuators and no electronics on the actual arm itself? So all your electronics are outside your hazardous environment. Another example is wind turbine inspection. So the gearboxes in a wind turbine are typically inspected using a manual boroscope, and it can take an engineer several hours a day to do this inspection. So could you have a robot that with a pre-planned path that it can just go in and inspect your gearbox, making the test more effective and efficient? Something we were looking at CC is the automation challenges of a global railway system manufacturer. So parts underneath the train need to be regularly inspected. You need access pits to allow operatives to go underneath and inspect these trains. But the problem is there's a limited number of pits. So what we wanted to do was explore a robot that could reach underneath the undercarriage of a train and reduce the demand for pits. So what did we do? We've developed a prototype. You might have seen quite a few of these online, but what we have done here is we developed a tendon-driven robot which had a nylon core with fiber optics embedded down the core. So it has 3 segments. You can see here, you can see this, but the black segments, the black discs, where the segments terminate. So each of those segments has 3 motors driving it, so you can have individual control of the 3 segments. The whole thing is on a linear rail, so you can move in and out of the place of inspection. Then we have position feedback, so we reconstruct the shape of the robot using an optic fiber interrogator, which takes the strain readings across the whole length of the robot, which we can then reconstruct the shape. We also have a sensor fusion algorithm where we also bring in IMU measurement units that are faster and complement the high accuracy of the fiber optics. So, one sec. What did we do? To model the robot, we developed a nonlinear forward kinematics model based on the Kosterad theory. So that can take in large beam deflections, and then using that, we used a shooting method algorithm that takes in the boundary conditions of each segment and allows you to get the shape of the robot. So what you do is you input the tendon forces and you output tendon actuations and robot poses. And then what we did using this model is offline, we generated a database with millions of poses that we could then use a pathfinding algorithm to have set points where the robot could follow. We did all this in a ROS architecture, so you can see the schematic here of what the robot is doing behind the scenes. And next we have a video, which I hope plays, Here we go. So this is what we call Project Slither. You can see on the right of the robot is the actual actuation body. And then the whole thing is moving on a linear rail. And you can see here, we're just showing off some of the poses and dexterity of the robot. And then you can see on the bottom right here, the shape reconstruction algorithm working behind the scenes. And you can see here, it's just moving into a sweep of motions that we, in this case, have pre-planned. And then next, we have the robot going through a tortuous path. So it's going through 2 holes that have been pre-planned, and the robot goes through. You can see the shape sensing algorithm here, and we've also got an FPV camera that allows us to go into the area that we're inspecting. In this case, we go into a black box. And then we have a prototype in the other room, which I'm happy to show you, and you can see the fiber optics in the nylon core and ask any other questions you have on the algorithm or whatever we're doing. I'm happy to answer them. That's it. Thank you very much.
So do we have any questions on what Cambridge Consultants can do for you? Sorry. So the question is if it's fully autonomous.
You mean the robot itself? You mean where the path it follows? Generally. The one we have currently is pre-planned. So we give it set points, and then it finds the best path it should take to reach that. Now, you could go a step ahead where you have another set of features that could automate the process of picking those set points. But this one you saw currently is pre-planned. Well, yeah, I mean, it depends. So I guess you'd have a whole session on the safety part of the robot. But for this prototype we were showing, we're just trying to demonstrate the reconstruction of the shape and the feedback loop. But yes, you're absolutely right. Safety of an autonomous robot is a whole different ballpark, especially if you're talking about the medical sector.
Thank you. Thanks for that. And as you said, Cambridge Consultants will be around, and they can probably answer a few questions if you have a few more after this. With that, we call up Extend Robotics. So I'll put that one there. Just okay. If you hold that one first, I'll put this is for the live stream. Yeah. So over to you.
Hello. Yeah, thank you so much, Tom. Feel free to stop me if I'm talking too much, and yeah, I'll try to keep it within the time. I tend to speak a lot. Yeah, so hi, my name is Chan. I'm the CEO and chief designer of Extend Robotics. So we built robotic software to extend the use of robots, just making robot much easier for people to use and more accessible. To ultimately build this kind of remote physical workforce through metaverse, robotics, and AI. A little bit about myself. I started the company in 2019. Before that, I was a postdoc at Imperial College. I spent about 10 years in robotics and AI. So I put together a quite technical team, really trying to develop this interface. And some histories about we've been in the Dragon's Den, BBC Dragon's Den, one of probably the first one that actually dared to demonstrate a real live demo, robotics live demo on the stage. And yeah, so that was quite a splash. And then recently we've been working with the BT, RAR UK, Airbus for further commercialization projects. Yeah, so what we do specifically is about building this intuitive human-robot interface software with virtual reality technologies to enable non-robotic experts to intuitively operate robots, either real-time operations or program the robot for automations. So yeah, so a little bit about the challenge we're dealing with here is really about moving the robot from those factory automations that traditionally you use to build cars. Those robots are not intelligent, but they're repetitively moving stuff endlessly. But we want to say, what's the next for those robotic systems? We want the robots to really go out of the factory and go to the real world. But the challenge for real world is there's a lot of uncertainties, variabilities, and it's really hard. So at this point, it requires a lot of human in the loop automations that augmenting this human intelligence with robots so that it can be more capable. So we're really fitting into there to combine this human part of the story with the robots in a very intuitive interface. And what we want to develop in the future is about combining that with automations that we can have an automation co-pilot that accelerate productivities with robotic within the same interface framework. So specifically about the product we have is a virtual reality app that really runs on a virtual reality, any gaming VR headset, Oculus, Steam headset. It is able to stream really low latency, high definition 3D data that is rendering around the robots, that giving this 3D perceptions. And so it uses consumer VR equipment as a standardized interface to operate a wide range of third-party robots. So there's a lot of robots that we already support that people can use, such as universal robots and power robotics. Quite a few options that people can choose to fit for their purpose. And so why VR? So there's a lot of research already conducted about how transforming a 2D interface into 3D could greatly enhance the speed of operations and reducing the cognitive workload of operators, and really improve the usability and satisfaction score. Ultimately, what you get is a much less accidents, much more efficiency when operating the robots. So we're quite down the line in terms of working with industries. One of the applications we've been working is the nuclear. Is a nuclear application that is trying to remove people from those radioactive environments, but still allow them to work in very dexterous tasks. The other application is the space. So similarly to nuclear, you don't want the astronauts to constantly risking their lives in the space. We can enable in-orbit servicing and manufacturing applications in the space, but also in space exploration tasks. And similarly the agriculture applications, and that's been working with Innovate UK grants and manufacturer applications as well. So yeah, feel free to come to me and to discuss a little bit more about the applications we've been working on and how we can work together on further projects and pushing this industry forward. Thank you.
Okay. So any questions for Chang before we hand over to the next presenter? Yep.
Yeah, so latency is one of the main advantage we've been developing. We've been developing this patented algorithm that's minimizing the latency on compression and streaming of 3D data. We can reach less than 100 milliseconds latency on the software level, but obviously the network latency adds on top of that. So so typically, depending on the distance of the remote operators, they can log in over the internet, but obviously if they are like from US or Dubai, it took a while. It's like you can add maybe 100 milliseconds or 200 milliseconds of network latency on top. So so overall we would say 300 on a practical real world situation.
Is that one way?
Sorry, perhaps if you have any other questions, you can take them outside. They have a stand outside as well.
Sounds great. Yeah, that's great.
Thanks a lot for that. Sorry to be quick here, but everybody wants to get onto the networking as well. Big thanks to Chang for that presentation. So with that, over to Recycle. By the way, guys, in the back, if you want to have a seat, there's a few seats here in the front as well. Yeah, so you can hold that one, and I put that one on you there. Yes, so awesome.
Lovely. All right, thanks very much for having us here. I'm going to grab this one. Oh, and that is, there we go. Yeah, so my name's Jonathan. I'm from Recycle. I'm a mechanical engineer. And we are delivering computer AI-driven recycling and waste sorting solutions to the waste management industry. So this is an industry very much in need of automation. This is people in not nice environments. So there's a lot of advantages that we can deliver here. Obviously, you guys will be very familiar with a lot of the advantages of automation, but they're very much the same here. So there's consistency in our product. It can run day and night non-stop, which gives plant managers very reliable numbers that they can work with. There's cost reduction. Obviously, robots are cheaper to keep in the factory than people. There's visibility. So on the AI side, it's obviously driving our robotic solutions, but it's also giving data to our clients that they can use to understand the ins and outs of their plants and the purities of their output streams and things like this. So yeah, who are we? We're a company founded in 2019. We've grown to about 50 people now. We're UK-based, and we've got 45 systems installed across 8 countries across Europe. And we've got three products now, which I'll come on to in a bit. So yeah, we're working with some quite big names and partners in the waste management industry, really across Europe. Our robots are beginning to gain traction because, again, there is a big demand, especially with all of the labor shortages that you guys will all be familiar with as well. Yeah, so our 3 solutions, obviously the AI, the vision side is giving that trend data to our clients, as well as driving the sorting solutions. So we have 2 sorting solutions at the moment. The robotics the solutions, which is we're using a FANUC 6-DOF arm, and that is a very targeted solution for the quality control. So that's coming at the back end of the plant, really taking out anything from the stream that shouldn't be there. And then we've got the AirJet solution, which is the accurate but high volume sorting. So that's coming nearer the beginning. The robots can give you 4 sorting bins, essentially. So 4 different classes that you can, or places you can pick 2. The AirJets will give you 2, but at a very, very high volume. So running much, much faster. So yeah, I'll let this one play. But you can see here we've overcome some of the challenges. This is GIF, so I might have to let it come around if it gets there. We've overcome some of the challenges of AI, black items on black belts, things like this. We can also differentiate, which, again, compared to a lot of the machines already in the plants, we can differentiate between things like aluminium cans and aluminium trays, which can be important. We can also differentiate between food grade and non-food grade plastics, which often don't have any chemical difference. It's just if they've been used for a non-food grade purpose, then they can never be food grade again. So this is very, very high value to our customers. I'll show you the robotics solution, as we're a robotics event. So typically, as I said, we've gone with a FANUC 6-DOF arm. This is about 75% lighter and a lot easier to retrofit, which is the main advantage to our customers, is that we can come in on existing belts and existing spaces with very little modifications needed on their side. And that's 75% lighter compared to some of the other solutions you'll see with delta arms. Obviously, the size, the work envelope of a delta arm compared to a 6-off arm means you need a much bigger robot for a delta. And again, having a 6-off arm means that we can make the most of having a robot that can swoop and rotate and point to a bin and get our pick cycles much, much quicker. No empty movements. We've got a pressure sensor. We can detect if we've got an item on the end. Obviously, there are some very, very funky shaped items. We're not going to get every one, but we can mitigate the time loss and not go to the bin and just go straight away for the next item. So with that, I'll show a robot in action. You've got a little montage. Right. And that is it. I'll leave it on that one to Luke for any questions.
I'll take that one.
Yeah.
So then we ask any questions before we go on a break. So you're holding everyone back from the break, yeah? So yes, right.
Are you using your own vision system, or are you using
Yeah. So it's our own vision system. That is a big part of our product and what we do.
Awesome. There was one more question down there, yeah. So before we go on a break, yeah.
Are you manufacturing in the UK, and what are your major bottlenecks?
Sorry, I didn't catch the second part of that.
Do you have any major bottlenecks you face with manufacturing in the UK?
So yes, we do manufacture in the UK. No, we typically have not found any bottlenecks yet. Like I said, we're partnered with FANUC, so I should say all the manufacturing for everything else we do is inside, but obviously third-party FANUC provide, or we buy from FANUC, the arm and the controller. So we're building the pneumatics and the frame around it, and no bottlenecks there.
Awesome. Right, thanks a lot for that then. And again, you can all talk to presenting companies and so on. We really like to run a tight ship on the presentations because we think the networking is really, well, presentations are really good value as well, but networking is where the real value perhaps is. Yeah? So off you go and network again, and I'll see you in half an hour. Yeah? So. really likes to network hardcore, but if you can make your way back into the presentations, and then we'll kick off another round, and after that some more networking. So come on guys, it's almost like in an airplane when you step in, yeah? Just run in and take your seat really quickly. So for those people who are with us on the live stream, we're back again and looking forward to the presentations here again. Do we have James here from... So where's Strongpoint then? Ah, there we go. Let's kick off directly so we get this vote going. If you hold that one there, I will put this one onto you. It's for the live stream. Excellent. All right.
We've got the clicker, Tom. Tom, got the clicker.
Oh, click here. Click down.
Thank you very much. My name's James Palmer. I'm the VP of Automation, Robotics and Professional Services at Strongpoint. I look after everything effectively from automation and robotics as a product through to solution design and implementation. So who are Strongpoint and what do you know about Strongpoint? We're a Norwegian business. We've been in business for 35 years, 500 employees, and we're spread across 20 countries. We've got an office in the UK in Birmingham, Sweden in Stockholm, all of the Baltic regions, Spain and in Oslo. We also have a number of partner companies in the US and other parts of the world. Who are we and what do we do? So we're a retail technology provider, and we've actually been providing e-commerce solutions since 1999. And we have a full portfolio of products that works from supply chain all the way through to front end and stores, from auto store and fulfillment technology with a WMS, through to in-store fulfillment, our own in-store picking, grocery lockers, last mile delivery solutions. So everything you touch in a supermarket could be a Strongpoint product. If you shop in Sweden, there's a 95% chance that you're touching a a Strongpoint product. And actually in the UK, 80% of the retailers in the UK are currently using Strongpoint today. So we're high penetration of our products. Some Strongpoint e-commerce in the news. Sainsbury's recently selected us to roll out their in-store picking and replace their incumbent in-store picking provider. And we'll roll that out for the rest of this year and early into next year. So when you shop on Sainsbury's.com, that'll be from a Strongpoint platform. We've also delivered the first frozen auto store, and that frozen auto store is in Norway, and it's actually a multi-temperature grid. So we have technology that takes frozen auto store to -25 and works on the same grid as a chilled +5, and also an ambient temperature operating as one grid. So this is a little bit different. We're not here necessarily to sell Strongpoint, but it's about partnerships and what robotic startups look for and what partners look for. And our partner portfolio is quite varied, and actually testament to Tom and the team. We've got one of our partners presenting after me. One of our partners presented the last time we were here, and a couple of the other partners have been to a couple of the events. So as I said, we're an auto store partner. We have Blue Yonder as a WMS and a WCS, where we've written our own modules. Coalescent as today the only in-store AMR that works publicly, but I won't steal Cleo's thunder. Lopad, who are deeply ingrained in grocery and logistics AMRs. Covariant as robotic piece picking. We own part of 1X, which is a humanoid for working for consumers in logistics space and retail space. And Tharsus, who operate logistic fulfillment solutions on a bespoke requirement. So the importance of startups in the industry. Innovation is the heartbeat of progress, and in today's industrial landscape, robotic startups serve as the pioneers shaping the future of automation, efficiency and transformation change. When things are getting closer to the city centres, we're urbanising, there's nothing more as a solution design person, as an engineer, seeing lots of expensive conveyors bolted to floors, and it's about moving away from that technology and embracing robotic startups and how we can move away from some of that legacy early technology into new technology with new AI and empowerment. And what I would do is encourage you really to talk to end users, talk to integrators, and have a look at what the end users are saying, what the integrators and potential partners are saying, and help you with feedbacks to better align the solutions to real-world applications and market demands. So what should a startup look for? So everyone's looking for a golden ticket, everyone's looking for money and funding. But what is out there that could help? There's lots of different companies that can integrate technology and integrate hardware, but what should you look for? So complementary expertise. Seek partners with expertise that complement your own strengths. Many people in this room will be engineers, deep engineers, whether it's from a hardware or software perspective. You don't necessarily need to go and partner with someone who has the same skill set. So it could be looking at what different skill set and what attributes are in that partner network or in that company that can last. Access to resources, market access within Strongpoint. We work with over 200 different retailers. We have significant market access, technology synergy, and shared visions and values. And what does a partner look for? We look for innovative solutions. What do you bring to the market and how marketable is that product? The reliability and the support. How can you maintain that product? How do you ensure that a consumer or an end client is going to be able to make sure that the uptime is there and that the feasibility of a payback is there? Transparency and communication. Talk honestly in meetings. If you're behind, everyone gets behind, projects fall behind. Talk transparently, communicate very clearly, and work with the partner and with the end client to ensure that effectively what we're serving to the end user is delivered. Value proposition and a long-term relationship. So partnerships are built on trust and collaboration, and partners expect that robotic companies invest in building long-term relationships. And a quick summary, because I know we're tight for time. Importance of understanding the end user, benefits of engaging those end users and integrators for product development, emphasize on the commercial viability and fit alongside the technical innovation, encouragement for feedback, support, maintenance and serviceability, and gain those really important market insights and the client expectations. If there's any questions, let me know, but networking is probably the right place for this if you want to learn from the experience that we've got. Thank you.
Thank you. So James, thanks a lot for that. I really wanted to have some people from industry who have worked with startups and so on as well. So if you have your own startup, I hope that you can come and talk to James in the break, and perhaps he can give you some pointers of perhaps what you should think about and so on as well. There's plenty of experience in this room. There's plenty of new people as well. So, but yeah, just network. Yeah. With that, we are jumping over to Bo. There's that one there. I'll try to fit this one here. So, okay, fine. Thank you.
Hi everyone, I'm Nick, CEO of Bo. So what's Bo all about? Implementing robotics is a risky journey for companies that try to develop robotic solutions because the upfront cost of choosing, acquiring and learning hardware is very significant and carries significant risk. In Discovery, we found that roboticists are spending 80% of their time rewriting software for different hardware platforms because the code they write just isn't portable. So Bo will help you develop for all robotics, regardless of the type of robot, the manufacturer or programming language. Here on the screen are some of the examples of the type of robots supported by Bo and are out there now. And the solution is our patent-pending universal software platform that connects robotics with mainstream software development and enables people to write robotic software without necessarily knowing the target robot. We'll save anyone looking to develop a robotic solution months of work and potentially tens of thousands of pounds in costly errors in choosing the wrong hardware. we democratise robotics coding with popular and mainstream programming languages, enabling all software developers, not just specialist roboticists, to create applications for robots. Bo provides a better journey. That question of which robot should we buy and learn now becomes a simple, low-cost, low-risk decision because of the inherent portability of the solution. So with Bo, you can code for the virtual machine and then select and test different robots before seamlessly migrating to real hardware without rewriting any code. So this is a market that's growing dramatically, as you can see here from this BlackRock slide. It's the perfect time for Bo. And we think we can capture about 2% of the invoice value for our stack. So we have a total addressable market of $780 million and a business that we're launching that is going to be hopefully driving revenues of 100 million ARR by 2030. So this isn't a new idea. In the 1980s, Microsoft launched DOS and shortly thereafter Windows, which was the ultimate example of building an agnostic software platform for a fragmented hardware ecosystem. But in robotics, this has been difficult because of the complexity of the different form factors, such as humanoids, drones, quadrupeds, and so on, because ultimately no robot is the same as the other. So looking at the market, there's some competition for what we do, but we think these are cooperation really, because we have a unique part of the stack that enables the portability, the democratization of robotics development and application streaming that is not provided anywhere else in one solution. In fact, Bo can extend the reach of all these platforms and can work with them as well, saving our customers months of development work. And our pricing model is to charge per seat for a simulation license as part of a SaaS model, which drops into a cost per robot subscription for when you are commercially deploying. And manufacturers can also pre-bundle runtime licenses with robots, a bit like an OEM license. And we've got some established relationships with some hardware OEMs. We've just exhibited at the Hanover Messe with some really interesting quadruped robots. And we're working with prominent software houses and robotics integrators who are actively building end-to-end solutions with the Bo platform. So we're targeting sectors such as manufacturing, hazardous environments, healthcare, and agriculture, just to name a few. But there's plenty of use cases for this platform. So just a little bit about the team. I'm Nick, and actually I'm a former CEO of a large software dev house, which I exited last year. Daniel, our co-founder, is with us here. Daniel, wave. And he invented Bo whilst being a researcher at the University of Sheffield. And we also have some academics in our team as well who specialise in developmental biology, computational neuroscience, and cognitive robotics. And we have a great board of advisors. So that's us. And by the way, we are raising a seed round. So feel free to get in touch and learn more if you are an investor and interested. So please take a photo of my QR code, but I will be out the back to answer any questions. That is my presentation. Thank you very much.
Thanks for that, Nick. I'm very, very happy because that was spot on 5 minutes. So that makes me a really happy person. Any questions before we jump on to the next presenting company? Obviously, if you do have questions, which I know most of you do, you can also talk to Nick and his team outside in networking later.
Thank you.
Take this one. And with that, we jump over to Coalescent Robotics. So you hold that, and I will give that to you there. That's for the live stream. Thank you. 5 minutes.
I'll give that back to you.
Already?
Or do I need it?
No, you need it.
Oh, that's the live stream. Oh, okay, right. Technology, huh?
Click down.
Down. Yeah, so my name is Cleona Martin, aka Cleo, and we've developed a mobile robot for the retail industry. for the retail industry. So we're actually moving in the supermarket during the day with people. We've been working with the largest supermarket chain in Denmark for the last 4 years. So we've been pretty much living in that supermarket. And so we have quite a large understanding of what their issues are. And our product and fleet management system has been developed knowing really well what the customer needs. 40% of the time spent in supermarkets is walking around moving stuff, and it's a non-value added task. And obviously, retail, everywhere is lacking this. It's a shitty job, so no one wants to work there. What I'm going to talk about today is our fleet management system. We decided to, because we're again focused on this industry that's not used to robots, so we wanted to have a plug-and-play solution that doesn't need like so much change to your infrastructure, so that it's a quick decision for them, quick quotation marks. And so we have the fleet management system along with the robots. So a lot of people just kind of build the robot and don't build the fleet management system, and then you need to get integration partners in, and that adds another level of complexity. This is, also the idea is to go in and first, like the two major areas of transportation of products are restocking and online order fulfillment. So that's our target. We currently address just the use case of online order fulfillment. We initially went after restocking, but because of Corona, our focus shifted to online order. And then when you're in there, like the application is to put an average of 10 robots in each store. We go after hypermarkets, 3,000 to 4,000 and above square meters. And then when you're in there and you've got 10 robots moving around, you have the potential of getting quite a lot of data, but that's like later stage. So these are the three areas that you need. So you're working in the store alongside consumers that don't know anything about robots, and also the retail industry doesn't know anything about robots as much as they might like to think they do. And so, you need determinism and predictability, because if the robots are moving around, you want to know, if you're a customer, what it's doing. That's safety, that's functional safety, but it's also like not to be intimidating to the consumer. Flexibility, the supermarket environment changes so much that you want flexibility in your system as well. And then usability, it needs to be easy to use. No one's going to use your stuff, no matter how smart it is, if it's not easy to use. And then this is our fleet management system, which I very much like. It's not like we don't have any AI in the back or anything. We developed, so here you have the map visualization, and then you have, on the first image there, you have the purple robot. That's a robot that's waiting around for a task. The green one is an activated robot. And here you have, the green is pickup and drop-off stations. And then we use the concept of waypoints. We also use VDA 5050 to make it interoperable. But then basically the waypoints, you actually define and you make the system deterministic, right? So the robots are always moving one direction, you define that and not the other. So it's not like you give it an A to B and it just randomly goes there. It has to go waypoint to waypoint. These waypoints also allow you to stop traffic jams and congestion. So if you've got 10 robots that are in there picking trolleys, you don't want 10 robots coming at you when you're in the store. And so you can use this locking mechanism, which means that each robot stops then behind it until the one in front gives up the lock. Like as an example, like here, this is a demo area, this is the entrance, and this is always changing. There's always boxes here. So we initially had two-way traffic there, but it was causing too much problems. So here you can easily put like a one-way street. And that means it's much easier for the robot to get along. Here as well we had, it's probably better here, but here we had the traffic going up here, but this is a food area, which means that there's a lot of people walking around here. Here's a non-food area. So the robots were going up that way and down this way, but they were moving in and out around people a lot because this is the area that's mostly used. So with the waypoints, we were able to just move that over because it's quite a large aisle, which meant that the robot was not stopping that much anymore. And here, because that's a smaller aisle, the robot just locks that whole aisle while going down there to the next, And then usability. You know, these people that work in supermarkets, they can range from 16 to 65 years of age with different variations of knowledge. And so our app is meant for them to be able to debug the robot if the robot gets mislocalized or has any issues. It's a step-by-step visual approach to let the person know what they need to do to get the robot out of that situation.
Yeah. So, Clea, perhaps you can wait a little. I'm sure there are so many questions on this. Yeah? We're very, very excited as well to have Cleo, a woman actually in charge of a business, a startup from Denmark actually. We get that very, very rarely. We always try to get more women on stage as well. And some of you here, perhaps, we even ask the founders of companies if they want to promote some of the women coming up and trying to talk in front of this audience. It rarely happens, unfortunately. But thanks a lot, and I'm sure you will be able to ask Cleo everything that she knows about starting up a robotics company afterwards. Thank you. So with that, we're going over to Ace Robotics. So I should tell you a bit quickly about is Ace here? So this is a PhD project, yeah, so you shouldn't think that this is a commercial product that is available anywhere. We're also very keen to get PhDs to show off what they're working on. It's sometimes very exciting stuff, like this time, of course. And with that, over to Ace. Sorry, there you go. I'll put that there. 5 minutes. Yeah, put that one there.
All right, thanks. Hi everyone, my name's Issa and I'm a PhD student at Queen Mary University. Today I'll be presenting my project on how a wearable robotic tail can enhance human balance during lifting tasks. So, lifting something heavy can really hurt your back, right? Well, it's not surprising, because when you lift something heavy, your body has to strain itself to stay balanced, especially if you're lifting something heavy in front of you or working in an awkward posture. And this can be the case in various industries such as maintenance, manufacturing, and logistics. This comes with some risks. For example, there is a risk of accidents such as slips when you lose balance, but there's also a risk of injuries such as back pain, which can come when you repeatedly strain your muscles. A robotic solution has the potential to increase health and safety in the workplace, as well as helping workers to maintain their productivity as they age. So there are some existing solutions already, such as exoskeletons and gyroscopes, which do a fantastic job of stabilizing the body. Unfortunately, though, they're either too complex and expensive or too heavy, which has limited their adoption. But is there a more elegant way to do this? Well, how does Mother Nature do it? Many animals use tails to support balance. And inspired by this, we've designed and built a wearable robotic tail which can measure what you're carrying and then move a counterbalance to support you. The robot is simple, making it quick to set up and use. This type of robot is called a supernumerary robotic limb, and it augments the body by adding extra motion. So to start with, we began with some modeling, and we wanted to make sure it was not too heavy. So we ended up with 3 kilograms for the counterbalance weight, and we decided to make the tail around 50 centimeters. So this means that the robot is viable to use for an extended period of time and does not cause an inconvenience in an industrial setting. So this is our robot, which I've also brought with me today. The motors at the end here have the dual purpose of acting as the counterbalance, as well as actuating the system. So they rotate using a capstan cable transmission system around the base of the joint. And there is also a encoder system here, and that attaches onto your hand as well, so that the robot can detect the distance between your hand and the object that you're carrying. This is a bench test of the system. We wanted to measure how quickly it could respond and also how accurately the movements were. So we conducted some tests there. And we can see that the tail is fast and is also able to move accurately. Moving on from that, we wanted to test the system with a human task. So we conducted a participant study that involved lifting a weight positioned in front of the body. We conducted this task in 3 conditions. One, in the active condition, where the tail is actively moving. We also conducted this experiment in the passive condition to understand the physical effect of the tail. And we also did it without the system to obtain a baseline of results. The results from this study show that the system is able to reduce the forward displacement of center of pressure when lifting an object. And we can see here some results, which we've also worked into a publication that we're going to be presenting at BioRob later this year. So a challenge that can come with wearable robots is that they should be tailored to fit your unique characteristics to be most effective. Attributes such as your height and arm span affect how you lift, and manually adjusting every robot would take forever. I'm also exploring using reinforcement learning so that the robot can monitor your muscle activity in real time and fine-tune its movements, helping it to embrace the diversity of all of us. Thank you.
So thanks a lot for that. That was even better, 4 minutes, 30 seconds. So any questions on exoskeletons? So you're very excited about exoskeletons, this audience, yeah? So I'm sure you will. Oh, there we go. So the question is, how much counterweight do you have to have?
So yeah, there's kind of two aspects to this. One of them is the distance, the other one is the weight of the object. In this initial stage, we have looked at only modeling the distance and using some kind of known weights to calculate that. But yeah, you're absolutely right. We would need the weight of the object as well to calculate the amount of counterbalance required. And we are also developing a handheld sensor system which incorporates some load cells to detect the weight of the object you're lifting to. Thanks for your question.
Awesome. Any other questions? Otherwise, we'll jump straight over to, I think it's Kaikaku that's up next. There we go. That's the one there, yeah. So that one, so I have to do this a bit later. I will ask the company to present as well. Do this a bit late.
Oh, okay, yeah, sure.
So we'll do this 5 minutes.
Okay. Hello, good evening. Welcome to Kaikaku, which means, does anybody know? Food. It should mean food. That's a good point. It doesn't mean food. It means radical change. And we are creating radical change in the food and beverage sector. I'm David Sharp. I'm the founder and chief technology officer. And in the next few minutes, we'll tell you what we're going to do. We're going to create radical innovation, a new wave of automation and robotics for quick service restaurants and food and beverage, using all the stuff that you use. AI, software, electronics, mechanics, sensors, rapid prototyping, and Onshape. We're making fast food, quick to prepare, quick to cook, quick to dispense, and late to arrive, because you're going to try some soon. Well, it's gone. Right, who is the Kaikaku team? It is the following. This chap was born in a Chinese restaurant in Vienna. And ever since then, he's been dreaming of running his own restaurant chain. And his dream is coming true. He's a serial entrepreneur. He's sold software businesses, made Austrian pancakes in London, Deliveroo type businesses. So that's him. He's joined by his friend Piers, who's the youngest crew trainer at McDonald's. So lots of experience in the food and restaurant business. Joined by me, I'm ex-Ocado, ex-Imperial, to help stabilize it all with tech. And we're also joined by a guy called Dr. Jakub Radzikowski, who is a culinary technologist and a PhD in microbiology. Amazing stuff. Then, just in case we get it all wrong, we've got some advisors. Don Furtman grew Subway to 30,000 restaurants. That's quite a lot. So we get some tips from him. David Crean was the chief scientific officer at Mars. We've got some tips from him about how to make it all hygienic and nice and food safe. And Jonathan Hart grew Caffè Nero and Thornton's, and he's helping us with restaurant strategy. Then we're assisted by Ivan, who's our founding engineer over there, who makes lots of mechanical things, which you can see outside, it's all those tubes. Louis, who's our design engineer, who's over here. Tinos, who's not here because he's busy writing software. Harry, because he's busy writing business plans. And we are joined from 3 of our 5 Imperial interns. You will stand up, you 3, and just wave. These are our fantastic electrical, mechanical, designy sort of people. So what an amazing team. What are we going to do? Oh, by the way, Tinos is going back to university. So if you'd like to be a software engineer instead of him, do let me know. David at kaikaku.ai. Right, what is the challenge? So we spoke to Piers from McDonald's. He said the thing that's really hard in McDonald's is getting any of the orders correct. Maybe you've noticed. You know, everybody's got different lettuce and tomatoes, and I do want mayonnaise or I don't want mayonnaise, and so it's just a nightmare. And if you go to a salad shop, you'll find there's, I don't know, 26 different ingredients, and everybody's ordered some of something and some not the other thing. So it's quite hard to get it right, okay? And so that's what we're going to use our robot for. So the robot looks like this. Instead of having the ingredients in front of you, you put them into tubes. You create some very clever dispensing mechanisms, courtesy of Louis and friends. And then exactly the right amount comes out. And the thing that's rather special about our system is, unlike a certain one called Sweet Greens, which is in America, which is similar, they have just tube after tube after tube with very expensive glass and stainless steel. And instead, we have acrylic and 3D printed plastic, food-safe material. And our stuff comes out in 6 or 10 at a time. So we are much faster. So we're creating a machine with 4, then 6, then 6, then 10. So we get 26 ingredients. A bowl goes in at the front, comes out every 30 seconds. But because we go in parallel, we can get bowls out every 7 to 10 seconds. Food-safe 3D printed parts available to see in there, and also available to see at our new restaurant. So here it is in live action. You order on an app where you decide how much of each ingredient you want. You scan your bowl into the machine, and this is station 1 with 4 ingredients. You can see lots of lovely green stuff coming down. There's just a conveyor belt to get us to station 2 of 6 ingredients. So things like sweet potatoes and tomatoes, things like that. This is the first time it worked. That's why everybody's so excited. And here comes some wiggly little extra things like sweet corn. And then finally, at the end, you only want a little touch of, a bit of cheese twist or pepper or salt, stuff like that. So if you look very carefully, you'll see some grains just drop out of here. Oh, did you see one? And that's it. There's your salad bowl. And the thing is, it actually looks like a salad bowl, even though it was made by a robot. And so then what happens is you think, my God, do I really only want salad for lunch? And the answer is no, please top it with something. And so then we get hospitality. So a human person, one of these people here from our restaurant, which is called Common Room, and is in the Brunswick Centre near Russell Square, will add on a piece of salmon, chicken, tofu, or caramelized goat's cheese, if you're lucky. So we've opened, we're live, and the robot's almost live. It will be live tomorrow, won't it? Oh, yes, yes, yes. And definitely by next week. And we're having this very special event on Friday when the robot will be live. So we've invited this guy, Eddie Hall. He's the 2017 World's Strongest Man, and he's going to see if he likes our salads. So that's happening at 12 o'clock on Friday at Common Room, as in University Common Room. And it's also Common Room because we've got a restaurant and a professional kitchen and a robot lab and a manufacturing facility all in the same common room. Unit 22, the Brunswick Centre, Russell Square, Tube. Hope to see you soon.
Well, one of the best performances today. Thanks for that presentation. Very exciting. Any questions before we know? Yes? Food? Well, we should go to that place. Was it on Friday, did you say? Or?
Friday is the weightlifter.
Okay, Friday's the weightlifter.
Yeah.
So I'll just take that. Okay. So with that, I want to hand over as well to James at Hill Dickinson to give us a few words and perhaps wrap up the evening as well.
Yeah, thank you, Tom.
If you, I'll just put that there as well.
Yeah,
so
then
it gets it.
Look, I'm the man standing between you all and enlightenment, it seems, with Kaikaku. So look, just very, very quickly, you guys are doing all these fantastically wonderful things with real physical products, generally speaking, that you can all see and touch and everything else. We're the lawyers that are effectively behind all of that, and you can't really see or touch anything we do apart from us, if you really want to. But look, so point being, we're here. We will help protect you from the start, make sure you don't fall out with each other, or if you do fall out, then there's a paperwork behind it. Make sure that going forwards, you can enter into all the right agreements with the right people and in the right way, and then hopefully do all the right things and sell in a few years' time, like one of the chaps did a few minutes ago. So look, come and have a chat with us. We're out there. There's Michael here, for example. There's Amy at the back there. Michael hangs around with lots of billionaires on lovely ships and so on, and life sciences people who who sell lots of exciting life sciences businesses and will raise lots of money for you. Amy will make sure that you go down the right route, make sure that all your dirty laundry is not is all sort of hanging out in front of your investors, to make sure that you don't have anything hidden in the cupboards for later on, that investors will come and say, hang on a second, that dirty laundry, you didn't tell me about that. So look, come and speak with us, and we'll go from there. Food time.
I didn't come down here for a reference.
Oh, cheers.
That one there, yes.
Oh, yeah.
It's all right, thanks for that. I think there might be a slight delay to the food, you know, when you're performing robots in real time as well. But feel free to go out and network. We might ask you to move out of the way when the food is arriving. So just bear with us, have a drink and so on as well. Thanks a lot for coming tonight. Have a good evening.